Good morning, learners. So we are here again for the second part of our video conferencing session. The topic of this part of this lecture is accident prevention and protection. And here with us we have one expert, Mr. A.D. Suresh Babu, who is Assistant Commandant Fire in CISF. So now I invite Mr. A.D. Suresh Babu to continue this session.
Thank you, Dr. Manish, and good morning to everybody. In your section, in the page number 44 of Unit 7, there is the first sentence you read it. The question is, why did this happen? Accident, why did this happen? What is the reason for accidents? Whether it is lack of knowledge or the lack of tools. And over a period of time, in my experience, I have seen in many plants, it is not the lack of knowledge or tools. It is the person's attitude. Attitude towards following safety rules, safety aspects, how the methods adopting. The complacency, the earlier lectures also told that the people has got 10, 20, 15 years of services, then they develop a certain confidence, overconfidence of false confidence that nothing will happen to them. And they end up in fatal accidents, like the earlier an example told that a jockey falls from his horse also. He met accidents from the horse itself. And he was with that horse for a period of time, over 10 or 15 years of a time, and he was so experienced in that, and at last he fell dead. A mahot who takes the elephant and he dies from the elephant. So the person, it is an inherent fact that every action we are followed with the chances of accidents also, everywhere. So we will discuss causes. Causes in electrical distribution. We are limiting this to the accident related matters, not to the electrical substations or the distribution lines. Because everywhere the causes of accidents is one or other similar. It is because of the negligent act, lack of proper tools, or any other condition. It is universal in fact. In electrical distributions, we see that flash and burns, incorrect placing of ladders, haste, complacency, unsafe tools, delegations. We will discuss a bit. Flash and burns in electrical circuit breakers, electrical cables, electricals, whatever be the installation, it is a uniform thing. In transformers, it often happens when it is in the wet type of habit. Incorrect placing of ladders. In fact, this is exactly in line with your curriculum. You are dealing with the transmission lines, distribution lines, where you have to, your persons has to elevate ladder or to use ladders for the repairing, maintenance or the distribution purposes itself. Unsafe placement of ladders. Where you places the ladders, how you places the ladder, how you utilizes the ladder, and how much support you are getting from your colleagues. When we climb a ladder, it presupposes that somebody from your colleague should be present at the lowest point to guard you, to hold the ladder in the correct position. Another point is the placement of the ladder, pitching of the ladder. In fire services, we call it pitching of ladder. How you pitch the ladder. There is a thumb rule is that you pitch the ladder at an angle of 60 degrees. 60 degree means, that means you pitch a ladder at a 20 feet height. The top, that lowest portion of the ladder should be away from 5 feet from the wall where you are pitching it. So that means 1/4, 25%, 1/4 of the length should be away from the base of the wall or the pole where you are pitching the ladder. After that, above and all this, the top rungs, we call the rounds, there should be 3 feet above that for the where you are pitching the ladder, where you pitch. After that, above also, the ladder should go beyond that, then at least 3 feet. in fact, it is correctly told in fire service that is, it should be above 5 feet, so that a person who goes to the top of the ladder can hold the topmost round of the ladder safely and can come down or move towards the, if you are placing in a building, he can land on the top of the landings or to the floor or the wherever. So ladder pitching, we disregard this, because in fire services we got 35 feet ladders. The total length of the ladder is 35 feet, and we got a working extension is 30 to 33 feet. So whereas the other ladders, which is people where it is convenient to take, is something around 20 to 25 feet. More than that, it is very difficult to take ladder along with a corridor, along with a passage. So your working ladder is limited to 20 or 25 feet. Where you want to work more than of that height, what we do is that we pitch the ladder as close to the wall. When we pitch the ladder as close to the wall, what happens? The slanting will be straight. So the chances of sliding down or falling from the ladder is more. And other things, the person who is climbing over the ladder will also lose balance because of he is going straight to the ladder top. A slight movement of him will disturb the equilibrium of the body. So the chances of falling down from the ladder is more. And this has happened when the other lecturer was telling that he has seen that the one part, not only the person falling from it, but the pole itself was falling down. So when such cases can happen, we cannot rule out that our ladder pitching, if we pitch the ladder close to the pole, cannot fall down. It will fall down. If we pitch it correctly with the angle propositions of 60 degrees, or if we keep the distance of 1/5, 1/5 or 1/4, the ladder falling down will be very remote. Another is slipping of the ladder from the top of it. For that purpose, if you cannot put the ladder on a correct position, you have to tie the ladder. If you feel that the ladder is not safe at the particular point because of some other conditions, you cannot pitch it and you feel unsafe, you tie the top of the ladders round with any objects available there. And you see that if you cannot hold it, there at least 2 or 3 persons stand below the ladder so that they will hold the ladder tightly. So you will not fall from it. So ladder safety is one of the major problems facing by distribution agencies. In Delhi, we have seen that so many accidents has happened from the ladders. In thermal power stations with the thermal generating units also, the ladders have been put in a very steep gradient. So the chances of falling down is more. But it is in a limited area. It is in a closed area where the movement will be restricted and it is very regular. But the ladder has been put on a robust construction and ladder is, it will not slip from that. But in this case, where the distribution company is using this ladder, it is a portable one. You are taking one ladder from one place to another. So there are chances of accidents are there. Another is haste. In India, what we got is everything we need within a matter of seconds. We are not ready to wait for the gestation periods. We are not ready. We need it, the result we need it in everything. And everything has got it has got its own time. It has to be followed. Then the complacency, I earlier told that, complacency. We got a feeling. Nothing will happen to me. Whatever happens, it will happen to somebody else, not to me. I am safe because of my experience and my knowledge and my might. I will not be subject to any accidents. So wherever this happens, in my experience, I have seen a case in one of the thermal power stations, a person who has 26 years of experience in circuit breaking, that maintenance operations and maintenance department, he has been sent to some other area, from one unit to another unit, where the circuit breaker is very old and the new one where he was working is the newest version, where the incoming is different than the outgoing, where the first unit, the incoming is in one level and outgoing is in another level, the bottom or top, and the second unit, it was reversed. Without knowing about the intricacies of it, he went there, and because of his knowledge and experience, he take it on granted and he touched it. the outgoing, because it is already off over. You have to take out the circuit breaker. He thought of he can do that because the outgoing will not be there, and he touched it bare hand, and 3 persons died. You will not believe 3 persons died of burns because these persons didn't use personal protective equipment. They didn't check it, and even there was in the front of the circuit breaker also there are supposed to be kept rubber mats, and that has not been followed. We enquired it and we suggested that why it was not being kept. It is that they are told that if you put a rubber mat there, it will have at least a 1.5 inch height. So that taking out the circuit breaker in an emergency, it will be difficult to push it. To pull it or push it, it is very difficult. So for that inconvenience too, they are unable to bear that inconvenience, they take out the mat from it. So how we behave it is that I told you that it is not that whether how much knowledge we got it in the accident prevention, how we follow this. And the unsafe tools. Another is, we got a habit in India that we never discard things. And you can see that 30, 40 years old scooters will be running in the villages. We never discard things. We kept it. And unsafe, it is like unsafe tool. There will be screwdrivers, pliers, everything, the insulation was gone, but still we will not discard it. I will be sorry to say that we got a system to purchase, but we does not have a system to dispose of. That is happening in our system. It is there. We cannot dispose it. If somebody disposes it, he will be punished also. Then delegation. Delegation is that the person who was supposed to supervise a thing, he delegates and he will leave for chai dene ke liye or tea or some other works. That is the delegation. We delegate. And it will be noted that a delegate cannot be delegated. Once you have been delegated for a work and further you are not supposed to delegate your work to someone. And if you delegate this also, it is to be delegated to a person who is competent to do that. A layman cannot do a repairing works. Layman cannot do electrical repairing works. But we are doing the electrical repairing works with the contract laborers who is coming from, even he didn't complete the higher secondary school also, but he is joined as a contract labor. Over a period of time, he gained experience and he will be put into do these major repairs. Then what are the unsafe conditions? There will be some, this is the person's earth. If you go through that, systems will be there. Unsafe conditions are there. They will be having a defective machines. Machines, if every machine has to be repaired or maintained over a period of time or within a period of time, it has to be overhauled. See, in thermal power stations, every year there is a system, planned maintenance, planned shutdown. All units has to be shut down for a period of 10, 20, 15 days to see that everything is okay. But for due to electricity, fuel consumption, your energy constraints, what we do, we pull up with that. We go through if 9, 10, 11 months, continuous working of 11 months, it has to be overhauled. It has to be checked for. The bearing has to be checked. The system has to be, every electrical connections, power supply, everything has to be connected, checked. But we did not do that. We pull off it. Then unsafe design also. The earlier stages, the earlier machines, when it was in the rudimental stage, the designs was not in the safe when it was developed, but we didn't discard it, and still we are keeping it. That improper illumination. Improper illumination in the working place is one of the major reasons for accidents. We got our systems, we got electrical currents, electrical supply we generate, we have electrical lights, sufficient numbers of it. But after that, it has got a life. It depends upon the quality of the item we installed there. But we failed to replace it with a new one whenever it is gone out of order. Then poor housekeeping. My colleague was asking how it is affected that poor housekeeping will be there. If you worked in a floor, if the floor is slippery, the chances of falling down will be there. Another thing is, if you put the material in a half-hazard manner, the chances of hitting you or that material hits you will be there. Lack of proper tools. We see the earlier question, there is one of the engineer who kept a axle blade in his pocket. It is a improvised method of tools for some other purposes. It is not an insulated one. but he used that tools to do some other works in place of some tools. So improvisation, we are very good in improvisation. And there is a engineering called Jugaad engineering in India. You may notice that. Jugaad engineering. We made it. That is called improvisation, slippery floor. Then unauthorized works. We take it out granted many works that the stipulated formalities we does not follow. Unauthorized work. There is a major accident happened in the world is the Chernobyl accident. Chernobyl accident, it has been done with, it is the perfect case of an unauthorized work. When they are going for a planned shutdown of the plant, somebody of that engineers who thought that we will do some other experiments. They want to see that how much the turbine will generate if they switched off if they taken out the steam from it. That is the costing, how far it will cost and how far that costing will generate electricity to see. For their safety systems are so high and good, they cannot do that. So unauthorizedly, they taken out the safety material, safety points, they switched off, isolated the safety, and they end up in blowing that thermal atomic power station. It end up in the major disaster because they have done an unauthorized work. Then recording. Recording is also one of the major causes for solutions. Why we are not reaching in a good solution? Because of our recording. Because all accidents are not reported. If at all reported, it has not been reported properly. We cooked up the reports. For what? The concocted report will be either it is for fault finding to fix somebody or to save somebody. So the report is not. It is not a sincere report. It is not a honest report. What we are getting, of course, we are one of the first country or the major countries in the world to making reports. We are very good in making reports. Our reports are so lengthy. Book bindings, we have to do the reports and nobody reads. Then all accidents, it affects the community. It affects the nation because all accidents has got cost. It has got direct cost. The person who was affected is the victim. Medical treatment, you have to bear from the organization. Then another is the compensation. Sometimes not only the medical treatment, sometimes you have to pay for the compensation also. The indirect costs, production related. If one system, if facility is breakdown for a day, it will have a compounding effect because it is related to some other things, some other facilities. So it will be have a related losses will be there. If a plant shut down for one day, the production loss will be something. It depends upon the generation, it depends upon the plant's capacity. So production related will be there. Another is the administrative and legal. Whenever an accident happens, you have to report within 24 hours and within 48 hours as the case may be. Then another things, the inquiries will be there, then the legal cases will be there, expenses is going, for everything money matters, everything money is involved, then loss of goodwill. Every organization has got a goodwill based on their performance in the society. Likewise our Indian team, there is a goodwill, we lost the goodwill, yesterday they lost, it is black out the goodwill. Why? Because of the performance of that. So likewise the company's goodwill also is in the question when it happens in the accidents. Then the penalties, the statutory committees, statutory bodies are there. They will impose penalties on your organization. Then how you can prevent this accident? Accident prevention is that. Prevention is better than cure, we know that. How can we do that? First, have a good housekeeping. We have to keep tidy, everything in good order in its place. That is a good housekeeping. Another is our good work habits. Of course, we got a good housekeeping and we does not have the work habits. Because the man behind the machine is matters, not the machine itself is matters, alone matters. The man behind the machine. And the man does not have a good work habits, nothing will happen. If you have to achieve something, you should have a good habits. Then you have to expect chances of accidents. That is the foresight. We got a two sides, foresight and hindsight. One thing after, if anything happens, we use the hindsight to criticize people, criticize the action. But if we can foresight, we see that every action, like the Newton's theory, every action has got a equal and opposite reaction, and everything is there is a chances of accident. If you glass fell down from your hand, then it is an accidental cause. And that the stacks, we saw the shards falling into the floor. If somebody walks on it without he walks on barefoot, the chances of getting injured. So everywhere this chances of accident is there. Chances of accident. We have to see that it is not that complacency. Again the complacency. We are got ignorant about the chances of accident. Then the identification. What are the accidents, the chances of accident, how it is happened, where it is happened, whether I am also susceptible to this. This identification will help you in save from the accidents. Then some probes and shields. You have to, it is not that your work habits alone can help you, but something to support for you. That is the probes and shields. That is personal protective equipments. When you are working with electrical installations, electrical gloves, safety shoes, and in some cases you have to wear, when you work in the chemical plants and everywhere, you have to wear some chemical suits also. Likewise, personal protective equipments, then the proper tools and the knowledge of using it. How to use how can we use these tools? That is also, and the knowledge about the installations, knowledge about the after effects, everything is there. And then the authority. Authority is the, what I told you earlier, a layman cannot work on electrical installations. You have to authority. Authority means the certificates you gain from the colleges, from this course. You have after the particular course or undergoing a training, you are authorized to do some works. That is authority you have got it. Without authority, if you are not a competent man, if you are not authorized by the government, don't do it. You are not supposed to do repair, even your electrical repair works in your own house. It should be done by a electrical repair authorized person who is authorized by the government of that particular state, if not central government. Then other is the ability to bear inconvenience. If you are asked to wear a helmet, there will be inconvenience. If you are asked to park your vehicle in some other places not in front of the MPC, there will be some inconvenience. And your ability to withstand that inconvenience, your ability to bear that inconvenience, that is matters. When safety comes, it is inconvenience. You take it in the one word, safety is equal to inconvenience. If your ability to bear that, withstand that inconvenience. And another is your courage. The person does not have a courage to follow safety rules. Why? In India, we are being taunted by the group norms. We are not seeing that what I can do. We see the other person's what he is doing and what he will tell. It is not my will. It is the other's group will. You have the ability to withstand the group norms. For that, you need immense courage. You cannot start. Because if you wear a helmet yourself, if you stop your vehicle in the red light also, your friend will taunt you. Hey, you are a Beowulf, you are a fool. Why are you stopping? You just pass it on. So there also you have to withstand that inconvenience, to withstand that group pressure, you need courage. And discarding. Discarding means you have to discard the old and improper tools, improper habits. Discarding, it is not related to the tools alone, your habits also. If you cannot discard your wrong habit, you cannot succeed it. Then fire prevention and fire protection of substations. We come to your subjects. Transformer protection. The basic is the transformer. From generating stations, it is from the transformer itself starts and to the end user. There are n number of transformers will be there. Various types of lines will be there. High tension, low tension, then cable trenches, electrical circuit breakers, so many things will be there. So transformer is the basic one. Transformer protection. How you protect your transformer? Then the proper grounding. Already it is written. Everywhere electricity has to be properly grounded. In the last 10 days before, there is an accident in Kerala. One person who was doing repairing work on a transformer died due to electrocution. And they are telling that before that they switched off the current. They served the line. But during the course of his repairing, some or other way electricity passes. How it is happened? They might have delingered the line, but they didn't post a person there to see that nobody operate the link. Otherwise, they will see that men at work don't operate this. They didn't put that, the basic, very minimum things, very bare thing. They didn't follow it. But it costs one life lost, and it will not come. Once it is burned, once it is lost, it will not come back. Lightning protection. Robust construction of the building, robust construction of the poles. The other cases where the pole also itself has fallen down. It has not made on the robust, it has not done robust construction. It has construction over a place where it is too much, the water table was very high, and it has not been taken care of. It has to be taken care of, the soil conditions has to be taken care of. That has not been done. Then, to deal with accidents, you need a standard operating procedures. SOP, we call it SOP, standard operating procedures. How to deal the situations. When accidents happen, not only the accidents, how to conduct the repairing, who is authorized, how you will do that. Once getting the authorization, what is the actions to be followed, how to report this before and after the work. There is a standard operating procedures. For every organization, for every work, it has to be made. Once you made standard operating procedures, that means you are seeing it before. That is foresight. You are using your foresight. So you expect that where the accidents will be happen. What are the chances of it? When you are discussing it, the people will contribute it. There is mock drills. Once in a while, say once in a 6 months, you do some mock drills. 2 days before, in my plant, the NTPC Badarpur, there was a mock drill. It is assumed that there was a fire in the cable gallery. It was not been told to anybody except the person who is the controlling officer or the safety officer. And it was a perfect road. So this type of mock drill will help you where you are and how you behave in an emergency, and where your equipments and appliances are in correct order, whether they can be relied upon. This can be only checked in a mock drill if it is due in the right perspective. If you inform to everybody that tomorrow there will be particular time there will be a mock drill, and everybody will be prepared and they will act as it. It should not be informed prior. It should be an element of surprise should be there in the mock drill. Then the routine checking. There should be a routine checking. Weekly, daily, weekly, monthly, yearly. There should be a checking program should be there. Which are the items to be checked, and what are the priorities has to be made. Transformer safety. That is a robust construction. It should be constructed in a well place. It should be according to the soils, the side related areas, and dwarf walls for wet type of. And nowadays it is, I think it is changing over to wet to dry types where oil is not involved. And dwarf walls is to, the purpose of dwarf walls make over the in the round beside the transformer is to keep the oil leakage from the transformer in that place itself. It will not spread to other areas. We have to limit that oil spread in that area. From there, there will be a soak pit. It will be taken to a, there will be outlet, that will be all the oil leaked from the, or the best from the transformers will be collected in a particular place. It will not be allowed to flow to other areas. When it flows to other area, it will endanger that area also. Then a good fire protection systems. Fire protection system for transformers, medium velocity water spray systems are the best one. Medium velocity, it is placed around the transformer in the distance of 2 or 3 feet, and when the time of actuation, it throws water in a very high speed over the transformer, and it mixes up with the oil also there. Emulsification happens and it extinguishes the fire. Here the high velocity water is required. It is not because the water will evaporate at a temperature of 100 degrees centigrade. If the temperature is more in that area, the chances of water reaching to that particular area will be less. It has happened in the oil wells in the Kuwait in the 90s when it has been burned by Saddam Hussein. Water is not reaching that particular place because before reaching that area, because of the radiated heats, water evaporates. So for that purpose, medium velocity or high velocity water spray systems are used. This has been in conjunction with the automatic detection system, because all the time people are not be available near the transformers to actuate the fire protection system. So it has to be linked with the detection system, automatic fire detection system. There are two types of detection is there. One is smoke, it detects the smokes, it detects the heat also. So here in transformer, automatic heat detection systems are recommended. See, this is a picture taken from a book of an actual fire. When it burns, once it is burned, nothing will come out. You cannot salvage anything from it. Once burned, it is over. And we go to the next session of this, that is firefighting. The basic firefighting knowledge I am going to give you. That is, to happen a fire, there is three things are needed. That is the fuel, heat and oxygen. Everybody knows it. We know everybody. Everything we know it. But still, I just want to give a basic knowledge of it. That fuel, heat and oxygen, it comes in a required proposition. It is not that everywhere the heat. It depends upon the fuel it burns. The heat requirement is according to the fuel. A paper required very less heat, whereas a wood needs much more. Earlier it was a fire triangle. Later stage it is found that when these three things come together, there will be another action taking place. That is the chemical reaction taking place. Because of this chemical reaction, fire persists. So we call it fire tetrahedron. And fires, according to the fuels, the burning materials, fires has been classified into four classes: A class, B class, C class and D classes. A class is all the solid materials except metals. All the solid materials except metals are comes under class A. And class A is written in a triangular background, in a green background. A means solid materials except metals. The second is class B. Class B is the fire in a flammable liquids. And it should be written like in a square, in a red background, class B. This is liquids like kerosene, petrol, diesel. These are the liquids normally we encountered. The third one is class C. We know the three stages of the matter: solid, liquid and the gases. Gas is the C class. And the fourth one, we already told that the first one is A class is solids except metals. So the fourth class is class D, that is metals. When the metal is involved in fire, we say it is class D fires. When a solid other than metals, we say it is a class A fire. If the fire is in a liquid, we say it is class B fire, and it is in a gas. In the gas, it is called a class C materials. Why this distinguishment has done? Because all these four materials have different characteristics when it comes in, when it behaves in fire. You cannot use water over the liquid fire. Once you use water over petrol or diesel, water has got the specific gravity differences with the liquid, the flammable liquids. It will go down, it will sink, and the liquid level will come up. So what happens when you are pouring water over a liquid fire? The water level will cause the increasing of the liquid level, and so if it is in a limited container, it may spill over to the other areas. So you are not supposed to, or it is not advised to use water over liquid fires. That is why this classification comes. This classification helps you in find out which are the type of extinguishing media you can use. In class A fire, you can use water or any materials, because wood and cloths and other things will not have a reaction with this water. But in a liquid fire, water is not supposed to. For that purpose, if the water is been converted into foam. It is like we are using when we are washing, we use detergents for it. When we use detergents, it help to form a foam, froth over it. So likewise, there is chemicals added into the water, and when we aerated it, the system is in the extinguisher itself, the aeration and the water, that will make spread the water over a more area, and it will float over the liquid. Then it comes to C. C is that whenever you switch, unless and until you switch off the supply of the gases, it is very dangerous. It is same thing. You can, how we switch off the fire in our kitchen. We switch off the knob. So there it is happened. We are limiting the supply of fuel to the fire. We are cutting off the supply of fuel from the fire. So we limiting the supply. So now we see that when we limit the supply, we say it is called starvation. We are starving the fire to death. Another, when we put water over a fire, it is, in fact, it is taking out the heat from the fire. It is absorbing the heat. It is taking out the heat from it. So that method is called a cooling method. When we are putting water based foam over a flammable liquids, we are covering the burning surface. When we are covering the burning surface, we are limiting the air supply to the fire. We are seeing the three things are needed. That is heat, fuel and oxygen. And here when we are cover the layer, we are limiting the oxygen supply to that. When any one of these is absent, fire will get. In the gas stage, we are seeing that we are limiting the fuel itself. We are taking out the fuel from the fire. So that is called starvation. And other one is called cooling. When we use water, when we take off the water, heat from the fire. And another one is we limiting the air. In fact, we are taking out the air from the fire. So three methods are there: cooling, starvation, another method is called smothering or blanketing. We are covering it. Methods of fire extinguisher: remove heat from burning surface or materials, that is cooling; remove restrict air from the burning surface, that is smothering or blanketing; and remove restrict fuel, that is called starvation. That is these are the three methods: cooling, smothering and starvation. These are the earlier classifications of fire. After that, over a period of time, when the experience comes, we see that some other agents are also, because the flammable liquids behave in some other way. Some flammable liquids, that is the cooking oil, it has got a different characteristics than the kerosene oil or petrol and diesels. It has been classed as class K agents. These are the materials. Class K agents are cooking fuels, vegetable or animal oils and fats, because this has got a high temperature. It hold high temperature with it. Because fuel, the petrol and diesel, it is very light up, it evaporates easily, and the temperature retainment is very less, whereas in this class K agents, the temperature retainment will be much more and much lengthy. To deal with this, there are, in fact, this type of extinguishers are yet to come in India, or it is maybe in some isolated case, but the materials used is wet chemicals, water-based solutions of potassium carbonate-based chemical, potassium acetate-based chemical, or potassium citrate-based chemical, or a combination of all this. In fact, this type of extinguishers are yet to be introduced in Indian markets. For other purposes, we got to fight fire, we are using water, foam, then another is the carbon dioxide. Carbon dioxide, we told about the air to disturb the proportion of the oxygen contains in the air. Carbon dioxide is expelled. So at a particular point of time, for a period of time, or the particular area, the proportion of the air is disturbed. So on that time, when oxygen is come down below a particular point, fire will automatically extinguish. Carbon dioxide is used for that purposes. And another one is dry chemical powder. Dry chemical, finely grounded powders thrown over the fire. And this also disturbs the air combination there. It cuts out the air from it for a period. But after that, there is a chances of reignition is there, because the powder will subside. Carbon dioxide will subside. It will dissipate in the air. So, but these are the four type of extinguishers we are used. One is water aceties, another is the foam extinguishers, then the carbon dioxide extinguishers, and the dry chemical powder extinguishers. But over a period of time, we see that these metals, dealing with metals is very difficult. Metal fires, of course, some metals does not burn in normal temperature. Iron also burn, it is not burning, it will melt 1400 plus temperature. But when it is in heat, it behaves very differently. If you throw water over metal fires, it reacts in a different way. So water are not at all recommended over metal fires. So we know that we learned it in the class 8, that is the reactivity series. Above the hydrogen, there are some metals it has given. Potassium, sodium, calcium, something like that. It ended with the zinc, iron, tin, lead. And below that, copper, mercury, silver, gold. These will not react with the water. So let us have a look of that. We put it in the enemy of water, pani ka dushman. Why? Potassium, we know that it will burn in the humidity. In the humid air it will burn. Potassium, sodium, calcium, if you pour water over it. Magnesium, in high temperature it will burn. Magnesium shavings. Aluminium, zinc, iron, tin, lead. Of course, when it comes down from the potassium, sodium, calcium, magnesium, the reaction level will be very less. That lead will be having a very less. Even from magnesium onwards, it will be dangerous. Why this has been included? There was a fire in one of the steel plants in 1999. That there was a particular material kept in the store for over a period of 10-15 years. When the fire happens in that, people does not know the constitution of the materials. They pour water over it, and subsequent flashover, 3 men died, 23 were injured. So when they cross-checked with the materials properties, it has been written in clear manners that water should not be used. Repeat, water should not be used. That material contains magnesium. So when in fire, it behaves differently. Otherwise, it will be normal to us. So we call it these metals as the enemy of water in relations to firefighting. Some other materials are there. That is thorium, titanium, plutonium, hafnium, zirconium, lithium. These all are there, but very rare. These are called very rare, and we never encountered such metals in our. This is a photo of an extinguisher. I will attention to this extinguisher placed in front of you. This is one of the extinguishers. We called it extinguishers. It is colored red. It has got a discharge horn. This type of extinguisher in front of you is a dry chemical powder extinguishers. We will tell you how the operation of the extinguishers. In slide we can see that a cut model of an extinguisher. You have seen the actual extinguishers, and see the extinguisher. This is the cut model of an extinguisher. How it behaves? There is a pipe going down, and in between there is a air cartridges. It is contained carbon dioxide. Now the operation of these extinguishers. See in slide you can see that one person is taking out a pin from the top of it. In your test it has been given pull the pin. I will request the students to see that. This can show this. That pin, that is the pin. See, that is the pin which is kept with the extinguisher. This is a safety pin. In some other extinguishers, there will be a clip on the neck of that. In this particular type, it is a pin, and some type of extinguishers, water foam will be a clip over the neck. This is safety clip to prevent it from accidentally operators. This is the first is pass. You have seen that in your test, that is the operation procedures pass, pull the pin. So he is taking out the pin. The second one is aim the nozzle. He catch hold of the nozzle, and it is aimed to the fire. It is like a rifle aims to the object. It is like that he is aiming to it. You can take it this one. This is the see. So this has to be aimed towards the fire. Third one is, you can see the slide. Third one is strike on the knob. No, here in this particular in the classroom example, please this classroom example. Here it is Q's grip. There will be two types of grips will be there. That is this particular extinguisher have a Q's grip. You can catch it. Yes. Now this Q's grip is not working because it has been secured by a safety pin. Before to squeeze it, you have to take out the safety pin. Since it is not operating, we are not showing it operation. Don't. So after that, this contents of the extinguishers will come out, and it is, since it is directed, you are aimed already the nozzle towards the fire, the contents will fall into the fire. So this is the three actions. You can remember it. Pass, that is the first one is pull the pin, second is aim the nozzle, strike on the knob where the knob has been given, or squeeze on the knob and sweep the base of the fire. So extinguisher operations, you can remember it is pass. Pass is the code word for extinguisher operation. Then when you fight a fire, when you operate a extinguishers, the major concern will be not the fire extinguishing alone. The major concern will be your own safety as it is. Remember to have a path of escape behind you. Do not allow the fire to get between you and the exit. When you have to be more careful where you are standing in relation to the exit and the fire. The exit should be behind you. So in the case of an emergency, or if it went out of control, you can have your escape easily. Then the other part of it, the first aid, in your section, it is mainly deal with the electrical shock. Once you find a person, what you will do that? Position the victim on the back and provide reassurance to the patient. Don't narrate the incident. There are occasions when you are taking out a victim from it and you started narrating him, and this will create further tensions to him, further problem to him, and he may go otherwise. So don't tell anything, you reassure him and you started doing first aid to him, which are how you can deal it. You see that electric shock treatment. In distribution lines, the major point is that one or in natural disasters or anything or any other reasons, your line will swear or fall over a person, or anybody comes under the line. So how to remove the line from the body? The person, there is two persons you have seen that. One person is squatting beside the body, another is standing. The person who is standing, he is holding a wooden pole and he is supporting the electric line, and the other person who is squatting beside and he is taking out the line with the help of gloves. He is wearing the gloves, personal protective equipments. And without wearing proper protective equipments, you are not supposed to handle live electrical wire. And other things also, when you see that an electric line, all the electric lines, unless you are assured, unless you have been told or assured, you treat it as a live wire. There will be some confusion. Somebody will tell you that the line is off or live. There will be confusion. When it is confusion, you treat all lines as live lines. And after that, for electrical shock persons, you have to give some artificial respirations to him, resuscitations to him. How you can? Because of the current passing in a high velocity, his vital organs may stop functioning. The major one is the heart itself will not be working, your lungs will not be working. So to bring it back, you have to put pressure over him. This is a method. This is a method. The person is lying down, and the person who is standing beside him, squatting beside him, applying pressure over his back. I will show you something natural. See, here in particular case, the officer who finds a person after electrical shock in a place, and first he is checking the persons whether his lungs and mouth ways are clear of that. First he clear his face, nose and mouth, and after that only he will give artificial respirations to you. See, this is one particular type of method where the person who has been lie down and he is standing, the person who is giving artificial respiration is squatting on the head side. He has been catch hold of his hand, then bringing that both the hands to the chest level and pressing. and after that the process we are unable to show in a video. After that he will take out both the hands and extend the hands, then bring back to the chest, and this will follow for some other times, unless and until he find a reasons to believe that he has, either he is dead or he is come back to normal life. It is assumed that unless doctor declared dead, you are not supposed to stop this. You carry on. Sometimes it may goes on hours together. You go to revive his normal, and you should remove the patient immediately to the victim, immediately to the hospital for first aid, not for first aid, further treatment. You are not supposed. This is only for first aid you are giving. Another is this is another type of C. He has put back the person. The other way he was supine. Now he is on the bellies. Now he is putting pressure. The earlier picture you have seen that the pressure was given from the other side. Now it is from the head side. This will be more efforts, and the pressure you exert to the body should be commensurating to the person's constitution. It should not be that you should pressure more over a child's body, because you have been told when you are lean together, you are putting your weight also onto the body, so that you will not be squeezing his body, because your weight is also acting on him. See, after that squeezing, he will take out the elbows outside. When you take out the elbows, the legs and portions will also expand. So it will help him intake more air to him. This is one more method. This has been narrated in your book also. This has to be in conjunction with the cardiopulmonary resuscitations that normally doctors used to do. You strike over the chest level. You give a punch, small punches over his chest level, and after that you put your one hand over the chest and you give punch to your own hand, and these punches will affect his head, heart, and after that in conjunction with you give artificial respirations to you blow air from your mouth to his mouth. So for safety purposes, say you can put a towel over the victim's mouth and you can blow from your mouth, and you should not continuously blowing it. You blow it and you take it out, then after that you carry over with the compression of the chest, and after that this will be going hand in hand. You do one thing and after that the congestion. So in this type you can revive the respiration of the victim, because shock is a serious condition and this can cause death also. So when we come to the shall we
I think now it is a time to invite questions and queries from the learners from various receiving centers as well as from the floor. So if you have any query, then please ask. In the meantime, I would like to request Mr. Suresh Babu to continue for 2-3 minutes. In the meantime, we receive the call, then we can answer the queries.
Now, one more thing I want to do is what is our role in prevention? That is our role as a person. What is your role? And everybody has got a role. It is not that one of the organizations or the head of the organizations is required to be followed. We start from the life to death. From this total process of our life, we are supposed to be adhere to safety rules. It is not that it is limited to a factory owners, a factory workers, or when you are riding it. Everywhere, we will be cautious about that. What are the safe, where we are doing it cautiously. And unless and until we have got some concern about others, if you does not have the concern about others, we will not follow safety. When we throw dust or anything to the street, we are disregarding the others. When we may be good housekeeping we have got a good housekeeping in our house, and everybody has got their house. They kept in very good tidy. But when it comes to the workplace or the public, they do lots of nuisances. This shows that we are, of course, even though we are aware of the safety, we are showing this. We does not have a regards to others. Unless we don't have a regards to others, we will not be fruitful in our effort. So another is be alert. Be conscious so that you will not hurt unexpectedly. I made a correction. You will not hurt unexpectedly. You have to be alert. Every time you expect something from this side. When you cross the road, you expect some speeding vehicle will be coming. When you are climbing a ladder, you expect the chances of falling down. When you are repairing a line, you expect somebody will go and put the what is it called switch fuse back. So whether you have to take, so everything be alert. Another is some soul conscious nature. Don't encourage anything which will become a cause for disaster. I am taking it in a wider perspective. When we are constructing houses in the flood zone area of Yamuna, in fact we are becoming a cause of disaster, because Yamuna has got a particular area, flood zone area, or we call water meadows, and that area Yamuna has kept, the river Yamuna has kept for that. When it comes in the flood season, it has to flow without disturbing others, but disregarding that we construct houses there. And in the flood season, once in 6 or 7 years, there will be major floods in Yamuna, and all the houses constructed on that will be flown away. Then we laments. And in fact, that was not a natural disaster. It was a man-made. It was a man-made disaster. I feel it.
Yes.
Then another is what I feel it. We should be self-disciplined. Self-disciplined. We need the courage to say no. Unless until we does not have the courage to say no to no, where the no is needed, we cannot do that. And you have to be self-disciplined. Then it should be when we ask to be self-disciplined, we should have a focused life. We should have a future-oriented, society-related, society-concerned. And if you put it in a one word, if I ask you, if you put it in a one word, what you have to be? And I say, be a patriot. If you are a patriot, if you become in the patriot in the full sense, that means you are taken care of everything. With this, thank you everybody.
Thank you, Mr. Suresh Babu. Really, that it's a patriot is a very big word, comprising of many things: discipline, your devotion, dedication, your confidence. Everything it takes care of. If you are a patriot, really you are a good worker, and you are winner. Do you have any question?
I think I have heard about you have talked about the classes of the fire. I have also studied that there was a class of E class.
E class. It is there.
That was the electrical safety.
Earlier, in fact, earlier it was being classed as 5 A, B, C, D, E electrical classes. So later of the electricity does not burn its own. When electricity burns, it generates heat, but it does not burn. Because of the heat generated, it burns some other materials. That material may be a solid one, that material may be a metal, that material may be gas or something. So when it comes to the material burnings, so electricity is not a material as it is. So they have taken out that E class, so it has been according to the material burns from the electricity. And when it comes to the electricity, you should not use water there. The major safety in electrical installation is that the limitations of the water. You cannot use water over it. So there we have the dichemical extinguishers, carbon dioxide extinguishers comes, because this is non-conductive extinguishers. Though there we have to have that. That is why the firefighting or safety of the installation is vital. Because when it started burning, you cannot fight it. You can fight a oil fire, you can fight a building fire, but when it comes in the electrical installations, all the fire service people are handicapped of that. Because you cannot, almost every extinguishing media which is easily available and easily applied, can be easily applied, is based on water. And electricity we cannot use that. So it is better we don't go for the firefighting aspects, we prevent it. Prevention is the electrical, you have to prevent it.
So therefore, as far as the fire extinguisher is concerned, for electricity related fires, what should be mentioned over here?
It should be mentioned, it is not mentioned. See, I will see you. A class, B class and C class, D class, 4 classes you will be seen on the A, B, C, D, it will be written on the, and in this carbon dioxide you have to find out carbon dioxide and dry chemical powder extinguisher should be used. No foam type extinguisher. There you have to see the type of, not the classes it is mentioned, type of extinguishers. If it is a water related one, you should not use it. So dry chemical powder is the best one, the safe one also.
Thank you, Mr. Suresh Babu. We had
Thank
a
you
very nice interactive session in which this was a very informative to all of us, as the rule should be safety first.
Safety first.
Convenience is later, safety first. So thank you to all, and this is the end of this second session. Third session we will start at 11:30. Thank you.